Hi, I'm Jacob. I'm a freshman.
Hi, I'm Nathan. I'm also a freshman.
Hi, I'm Kyle, and I'm a sophomore, and this is Team 134E from Pembroke, New Hampshire.
We're making this video for the CREATE U.S. Open National VEX Robotics Championship.
To start things off, we'd like to talk about our design process. This is our robot Goliath that we're going to be taking to the competition. But to understand where he originated from, let's take a step back and look at the first robot that we built. So this robot, called the forklift, because of the way it operates, was built in the spring to test game dynamics. We wanted to see the difference between the low goal and the high goal scoring, and also to see if lifting was obsolete or not. So we have a zip tie intake that intakes into a forklift-like launcher that'll push the balls into the low goal. And then to test the lifting, we built a pneumatic ramp that goes down for robots to drive up to get the 25.4-inch lift.
However, we decided that this design wasn't very effective in scoring points because balls scored in the high goal are worth 5 times the amount of balls scored in the low goal. And even though the ramps provided a lot of points, just 5 balls or 2 bonus balls and 1 normal ball would outscore that. So instead we created Goliath.
So for our intake, we have a surgical tubing roller here, and we've got 2 verticals here that can run independently of each other.
And those verticals lead to our shooter, which has 4 motors and a 7-to-1 ratio to our 5-inch wheel. And that ratio also goes to a 5-to-3 ratio for our 2.75-inch wheel. And that means that this wheel is moving slightly faster than this one, which gives us backspin, thus giving more lift and more distance we can shoot the ball.
Jake, would you like to talk about the strengths of Goliath?
Yeah. Goliath is very fast, it is very accurate and precise and consistent, and the complex code is very efficient in how it operates.
One problem that we had while designing Goliath was the intake system to feed balls to the shooter. What we had at first was, instead of the dual intake system, we just had one and with pieces of flat plate, and we'd hope that it would go to the middle without jamming. But we had lots of problems with jamming, and it just wouldn't go through correctly. So we had to design the system where we have 2 separate intakes, essentially, that are right next to each other, and we haven't had problems with that since.
The major part that made this work was the original designs that we've had were all passive feeding systems that put all the balls into one lane versus the 2. With this one, it's an active because we have some flaps bringing balls into a single line, so that also contributed to us being able to facilitate the balls better. What can we do to improve Goliath, Nate?
One of the improvements we can make to Goliath is a transmission system where, instead of using 6 motors always on the drive, when we don't need them and we're shooting, we can take some of those motors and divert their power to our shooter and vice versa, so we can be both faster and more effective at shooting. There are also some tweaks we can make while shooting long range, because while we're very consistent right up against the goal, we're not as consistent shooting from the box.
So our team has had a lot of community involvement. This past fall, the Boy Scout Jamboree was held at the Loudon racetrack, and our team held demonstrations for any scouts or anybody for that matter who wanted to participate and learn about VEX. So what we did is we had a bunch of little push bots that push the balls around just to give people an idea of what VEX is all about and just get people involved and get the name out there for VEX.
Also, during our state competition, 90% of the volunteers were from our team and the parents from our team.
Another thing we'll do is we'll have open workshops where other schools can come and work with us, and we'll help each other design our robots.
Finally, we also had several demonstrations done. We've done them for the 106 Hobby Shop. We've done them for Associated Grocers New England, which is one of our major sponsors. We've also done one for the Jewel Lodge, which is also another one of our major sponsors. So we try to get out into the community and just make people know that we're here.
We also have, on our robot, we have multiple sensors. For example, we have these 2 ultrasonic sensors, which are used for autonomous, so we don't bump into other robots. More important than that, however, are the encoders that we have on our shooter and on our drive, which, Jacob, do you want to talk about the drive?
Yeah, we have a 6-motor drive with what are these wheels called again?
Mechanism wheels.
Mechanism wheels that we can move in any direction. We can strafe and move diagonally.
Another use of these encoders that we have is for the autonomous period, along with the ultrasonic sensors. At first, we just set the motors to a certain speed for a certain amount of time and hope that we'd reach the same spot, but there were inconsistencies. So now these encoders make sure that we go to the same place every time.
Also, another use for these encoders is an active braking system. So what we're able to do is essentially lock our encoder value at 0. So if another robot pushes us, it'll change the encoder value from 0, and it'll tell the motors to spin in the opposite direction to apply pressure back to the robot. So this allows us to stay stationary and not burn out in the process.
Another set of sensors that we have that aren't in our drive are these 2 photo sensors right here. And what the photo sensors do is create a photo gate. And what that is these 2 sensors will detect the amount of light and calibrate themselves before every match, or like right as the match starts. So when balls come up to right here, it recognizes that, and we have a button that will run these 2 intakes to bring the balls up to here until it's detected. And what that means is that we don't have to worry about micromanaging every system of our robot. We just press one button and we don't have to worry about it going into the chute when we don't want it to.
Would you like to put a ball in to demonstrate this, Jake?
Of course.
So now to move on to the engineering notebook, we're very proud of our notebook. We've put a lot of effort into it to demonstrate our design process and just everything that we can about our robot. So here we have designs for a feeding system. This is one of the passive designs that we had, and it didn't work very well. Here we have a bunch of different designs for where we can shoot and what we can do with autonomous. And then here we have our PID code. So what this allows us to do is, depending on the firmness of the balls, it will calculate the speed error that the ball gives the encoder on the shooter to allow the balls to be consistent. So what that means is for a firm ball, when it gets launched, it'll slow the wheels down more. So the encoder will detect this because it has a set target wheel speed. And what it'll allow it to do is, with that drop of wheel speed, it will make the motors spin faster to make the wheel get back up to speed, so that the firm balls will launch the same as the soft balls, because the soft balls won't need nearly as much of an output as the firm balls do. So that aids us in our consistency. Here we have other designs for our intaking system that we have currently, and our gear ratios and what we thought for this. Here we have information about our 6-motor drive, and then we've got information on how we can make sure that our robot doesn't take in more than 4 balls, which is the legal limit. And then we've got battery code and other autonomous code that we would use at a competition. Here we've got a reflection off of a competition that we won and what went well and what we can do in the future to stay successful. And then we've got more code, and then just season reflections and what we can do to improve our robot. If there's anything that you have questions about, we'd love to talk to you about our robot. We love sharing with people. We love helping people.
Thank you.